Radar is made of an antenna and a receiver. Microwaves emitted from the radar antenna hit the water droplets. As the energy hits the water droplets, it is scattered with some of the energy being reflected back to the radar receiver. Radar will detect more than just raindrops. This makes sense considering radar was originally developed to detect aircraft. The radar used for weather detection are tuned to detect reflected energy from water molecules. In addition to rain, hail, birds, and bugs all contain water molecules. The more densely packed the water molecules are, the stronger the received signal will be. Therefore, hail, heavy rain, and flocks of birds will all return signals much stronger than light rain and clouds. In fact, clouds provide such a weak signal that radar is not a practical tool for their detection. Reflectivity is the signal that radar detects, and the unit of measure are decibels relative to reflectivity and have the symbol dBz. dB stands for decibels and Z for relative reflectivity. The color spectrum shown is a visual representation of the reflectivity values. Reds and purple colors indicate heavy rain or hail and sometimes flocks of birds. Bugs will be detected, but at a very low reflectivity and either show up as white in radar images or may be filtered out as signal noise and not shown at all on the radar image. Radar is an acronym for Radio Detection and Ranging. Radar signals travel at the speed of light. By measuring the amount of time for a signal to return to the radar dish, the distance to the weather event can be calculated. For radar maps to be created, it is important to know the intensity of the signal and the location that the signal is coming from. Storms generally move from one location to another. Radar can be used to determine the direction and speed that storms are moving. Multiple pulses will be sent toward an object. By measuring how quickly the distance and position of the object changes, the speed and direction can be calculated. The measure of speed and direction is referred to as the radial velocity of the target. Green colors indicate the target is moving toward the radar, and reds indicate moving away from the radar. The intensity of the color gives an indication of the speed that the target is moving. Along any direction, the intensity of the reflected signal over time tells us about the amount of stuff in a volume of the atmosphere at a given range. Radar dishes rotate and move up and down in order to get an accurate picture of the atmospheric conditions. A typical starting point is rotating the dish at a 0.5 degree angle, just enough for the signal to detect very close and near surface weather events, but at an angle that the signal will go above treetops and buildings. The radar will rotate 360 degrees at each angle, rise to a new angle, and rotate again. The radar can be programmed to rotate at any angle to get a clear picture of any weather events.